This is lesson 6.4 part 3. In this video we're going to finish the problem that we started in part 2 and then move on to a few other practice problems just so we really get the hang of interpreting and solving problems using our quadratic formula. So like I said, we're over here. We had to use this equation here to find the value of y. Don't forget to find first your a, b, and c. So in this case our a is -2, our b is -42, and our c is 216. 216. Erase that. So 216. We can go and plug that into our equation there. So we have y is equal to -42 plus or minus -42 squared minus 4 times a, which is -2, times c, which is 216, all over 2 times -2. And then we can clean that up a bit, and we get y is equal to 42, because -42 times -1 is 42, plus or minus root of, so 1764, and then minus 1728, all over -4. So that means that y is equal to 42 plus or minus square root of 36, all over -4. And now we can go and choose our, well, we can simplify a bit more. Actually, let's do y is equal to 42 plus or minus 6 over -4. And now we can choose our sides. We can do the plus side and the minus side. So we can do 42 plus 6 over -4. So y is equal to 48 over -4. So y is equal to -12. That's one possibility. We can do our other possibility as well. So for our other possibility we have 42 minus 6 over -4. Let me just make sure that my that actually is -4 there, just to double check. I don't know why I put -2y here. So let's go back and fix that, because it looks like my y should be positive y. So let's go fix that up here just to double check. So positive 2y. I made a mistake there, so it's positive 2y squared. Positive 2y squared. So a is positive 2. See, sometimes just a little mistake like that, and I saw that both my answers would be negative, and that wouldn't make sense, so that's why I went back to double check. So we have positive 2 here, positive 2 here. So that would make this positive 4, positive 4, positive 4, and then positive 12 here. So that works out there. So positive 4, just fixing that up there. And now it looks like we're on the right track. So back to this here. So y, the other option is y is equal to 42 minus 6 over 4, which is y is equal to 36 over 4, which is y is equal to 9. So what we've done is we found two solutions here. We have that y is equal to 12, or y is equal to 9. And so we can go and verify to see if those actually do work out. So for example, we can choose one of these values here to check if the other side is indeed the other side that you see over here. So let's go take a look at that. So we had written out an equation. We had said that, so we're verifying now. This was our step 3. Step 4 is just verifying to see if that works out. So we have y is equal to 9. And we know that x is equal to 21 minus y. So x would have to be 21 minus 9. So x would have to be 12. So what that means is that our two sides are 12 and 9 units. Therefore, the other sides are 12 and 9 units. And so we've solved that using our quadratic formula to find the length of the sides. So if you were to, and you can also check your perimeter as well to see if that makes sense. So 9 plus 12 is 21, plus 15 is 36. That works out as well. You can't just do guess and check. You need to make sure that you solve it for this particular system of equations as opposed to just guessing and checking random numbers. So that is our general process for doing a question like this. Let's go on to the next question with the digital sensor. You'll see I'll go through some of the steps quickly because you should know how to do some of them after the examples that we already did. And then other steps I'll go a little bit slower because we haven't done similar ones yet. So a digital sensor records the height of a baseball after it's hit into the air. Its height is h in meters and t in seconds, and this is our model over here, the equation that models that trajectory of the ball. When does the ball hit the ground? So when does the ball hit the ground? You need to interpret that means when is the ball at a height of 0. So in other words, you are writing this out. You're writing negative 4.9 t squared plus 20.58 t plus 0.491 is equal to 0. And then you're going to solve to find what your t is. You could try factoring, but as you can see, it's probably going to be a bit difficult to do with these type of numbers here. So what you want to do is, you want to use your quadratic equation. You want to find that t is equal to minus b plus or minus square root of b squared minus 4ac over 2a. And so you can carry it out much like we did with the other examples above. But what you'll get in the end is that you'll have two t values. You'll have a t value is equal to negative 0.02 seconds. And then you'll also have a t value that's equal to 4.22 seconds. And again, you need to make sure you're doing the work here. I didn't do it because you should know how to use it by now. And you need to choose which one makes most sense. So are you going to have a negative value for seconds? Probably not. You're probably going to select the one where you have a positive value for seconds. And so that would be, then you can write your therefore statement. Therefore, the height is 0 after 4.22 seconds. And again, you wouldn't want to factor this something like this because that would be very difficult to do. So you could use your quadratic formula here to do that. So let's go take a look at B. For what length of time is the ball above 10? So we have above 10 meters. So we have our, I'm going to draw a trajectory here. Let's just say that this is our parabola for the ball. We started off with the ball at around 0, 0, and then it comes back and hits the ground again eventually. And that there's some error there. I mean, the ball might be a little bit higher than 0, 0 because you might be higher than the ground if you're hitting it, but we're just not taking that into account right now. There's a maximum here. Now, assuming 10 is not our maximum, we're not going to really focus on that too much. What I want you to get is that the ball will eventually reach 10 meters at a certain time. It'll go up and reach the maximum, and then it'll come back to 10 meters at another time. So what that means is that this period of time here is the amount of time it was above 10 meters. So whatever this time is here and here, that's the amount of time. So let's say, for example, and this is just arbitrary, we didn't solve it yet. If this was at 2 seconds and this was at 5 seconds, and that means that it was above 10 meters for 5 minus 2, 3 seconds. So how do we solve this? Well, we know that we want our h is equal to 10. And so we're going to set up our equation that way. We're going to write that negative 4.9 t squared plus 20.58 t plus 0.491 is equal to 10. And then you're going to send this 10 to the other side here, and you're going to get your equation that looks like this. Negative 4.9 t squared plus 20.58 t plus 0.491 minus 10 is equal to 0. Then we can clean it up. Negative 4.9 t squared plus 20.58 t, and then you can figure out what that is in your calculator. 0.491 minus 10 gives you negative 9.509 is equal to 0, and then you can go and plug this into your quadratic equation, your quadratic formula, which is t is equal to, or x is equal to, minus b plus or minus root of b squared minus 4ac over 2a. And so let's go and plug that in. So we have t is equal to minus 20.58 plus or minus square root of b squared, which is 20.58 squared, minus 4 times minus 4.9. That's a times c, which is negative 9.509. Don't forget to extend that there. Over 2 times negative 4.9. And so I'm going to clean this up a little bit. We got t is equal to negative 20.58 plus or minus. Let's go see what's inside this root here with our calculator. So we have 20.58 squared. So that's going to be 423.5364. So 423.54, let's just say. You could round later. And then let's go see. So minus 4 times minus 4.9 times minus 9.509. So that's minus 186.376. 0.38 over, our negative 4.9 times 2, and that'll give us negative 9.8. And then I'm just going to finish the problem over here. So t is equal to negative 20.58 plus or minus square root. Let's go see what goes in there. So we have 423.54 minus 186.38 to 37.16 over negative 9.8. And then we can go and solve for our plus side and our minus side. And when you do that, you're going to see that you'll get two values, and I'll let you figure that out. You get t is equal to, let's just plug it in my calculator, 0.53 seconds. And also t is equal to 3.67 seconds. So that's what these values are here. So we have 0.53 over here and 3.67. So it spends 3.67 minus 0.53, which is equal to 3.14 seconds above 10 meters, above 10 meters, and you would write that as a therefore statement. We'll finish off the last example in the next video.